எல்லாருக்கும் வணக்கம். ஸோ இந்த ப்ரீவியஸ் செஷன் வந்து நம்ம வெக்டர்ஸை பற்றி பார்த்தோம். ஸோ வெக்டர்ஸ்ன்னு சொல்லக்கூடியது வந்து இட்ஸ் மேத்தமேட்டிக்கல் டூல், ஒரு மேத்தமேட்டிக்கல் சப்ஜெக்ட் ஃபிசிக்ஸில் வைடாக யூஸ் பண்ணக்கூடியது. நவ் வி ஆர் கோயிங் இன் டு த ரியல் ஹார்ட் கோர் ஃபிசிக்ஸ் செஷன் ஆஃப் அவர் கோர்ஸ். அப்போது த ஃபஸ்ட்டு செஷன் வி ஆர் கோயிங் டு ஸ்டார்ட் வித் இஸ் ஆக்சுவலி கைனமேட்டிக்ஸ். கைனமேட்டிக்ஸ் தான் ஒரு அனாலிட்டிக்கல் ஃபிசிக்ஸை பொறுத்த வரைக்கும் the preliminary topic. So the modern approach of looking into physics is actually based on kinematics. So kinematics is enna paapom. So it is a study of motion without looking into the cause of it. That means we are just observing how an object or something moves. Adu vand endha object move agudhu, like what is the object that is moving or what is the cause of motion, idha pathi ella nama kinematics il padikkiradilla. Just we are looking as the time goes on how the object moves. அது எந்த ஆப்ஜெக்டாக இருக்குங்கிறதெல்லாம் we are not considering. So whatever be the object and whatever be the reason that makes it move, it doesn't matter. So just by looking at the way by which it moves, we are going to formulate certain theories. This approach to physics is called kinematics. So kinematics has its beginning, can be greatly attributed to Galileo's approach, where he intensively used mathematics like geometry. இதெல்லாம் யூஸ் பண்ணி ரொம்ப சீரியஸாக மேத்தமேட்டிக்கலாக ஃபஸ்ட்டு மோஷனை அனலைஸ் பண்ணுறது வந்து கலீலியோ தான். ஸோ லெட் அஸ் see how we approach physics through kinematics. ஸோ kinematics பொறுத்த வரைக்கும் there are only two meaningful questions in kinematics. Those questions are where and when. That's it. So when actually corresponds to time, and this where is actually corresponding to location. So kinematics la nama enna padikrona, as the time goes on you can say how the position of an object changes. So position of an object in the sense means whatever be the object. So we start by considering a fictitious object, and the object க்கு வந்து size irukadu, so that the mathematics behind it is very simple. That object is called a point object. So we start with a point object. It's a fictitious object that doesn't have any size, so it is just like a point. And let us imagine the point moves as the time goes on, and let us analyze this motion using some precise mathematical techniques. That is the beginning point of physics. So our aim is to find out the relation between these two questions, where and when. That is, as the time goes on, how the object's position changes. So position as a function of time, you can say in some sense, that is what you study in kinematics. So kinematics பொறுத்த வரைக்கும் the nature of the object that is moving we don't consider. Nature of the object, like what is the mass of it or what is the size of it, இதை பற்றியெல்லாம் we are not bothering at all in kinematics. And the reasons behind the motion. So what is the cause of motion? Like force may be a cause of motion, or whatever it may be, somebody is making it move, we don't bother about that as well. So the only thing we are considering in the case of kinematics is the variables called position and time and the other related variables. So and the object at a location as it moves in time, and the observation and what are the other variables that we can conclude at. In the விஷயத்தை மட்டும்தான், this is the only thing we are looking in kinematics. But remember, it's a very effective way of looking into the physical world. In fact, in advanced level of physics, it is believed that by the more advanced stages of physics, it is believed that all the fields of physics will actually conclude into kinematics in its simple way. Or you can say the entire universe is actually built only with two meaningful concepts, that is location and time. The physicists call it as the space and time in more advanced levels. So kinematics is a subject which is need to be taken with utmost seriousness. That is why I am making that point over here. So these things we don't bother at all. What is the object that is moving and what makes it move, we don't bother at all. So what we bother is just the relation between position and time, or as the time goes on, how the position changes. So இதுக்கு ரிலேட்டடாக என்னென்ன வேரியபிள்ஸ் வந்து we are going to look. We are going to look at the principal variables that are derived from this observation, that is how the position of object changes with respect to time. So the first variable is of course displacement. Like let us imagine an object changes its position from A to a position B. Okay, so it can take many paths for moving from A to B. Suppose it moves in this path. So there are many ways of moving from A to B. So this is another path by which it can move. Now, if you place a thread, ஒரு நூல் எடுத்து இந்த பாத்தில் இப்படி வச்சீங்கன்னாக்கா அந்த நூலை மறுபடியும் ஸ்ட்ரெச் பண்ணும்போது உங்களுக்கு ஒரு லென்த் கிடைக்கும். That length is what you call as the distance. So that's a common sense word, how many distance that it covers. For example, you are driving from one place to another place. So the total distance covered is actually nothing but the length of this curved path. This is what you call as distance. So what is meant by displacement? You take the initial point and final point. Take the straight line distance between the 2 points. This fellow is what you call as the displacement. In kinematics, displacement happens to be a more useful concept than the concept of distance. So, displacement between 2 points A and B is actually the straight line spatial separation between the points in some sense. So, நம்ம வந்து further advanced kinematics படிக்கும்போது we will give a more meaningful definition to what is displacement. And the beginning stageல நீங்க எப்படி புரிஞ்சுக்கலாம்னா the displacement between 2 points is the shortest distance between the 2 points A and B. So, displacement as we mentioned happens to be a vector. So, displacement or meaningful நீங்க specify பண்ணனும்னாக்கா you have to specify the direction of displacement as well as the magnitude of displacement, and distance is considered to be a scalar. So the unit of course displacement, the unit SI unit of displacement and distance is meter, denoted by m, and the dimensional formula for it is L. So this is the SI unit of displacement and this is the dimensional formula for displacement. So remember, displacement between 2 points A and B is actually the shortest distance between the 2 points A and B, or length of the straight line that connects A and B, and displacement is that actually the length of the length of that path, the entire path actually taking into consideration of the entire trace of the path that it makes. So this test கண்டுபிடிக்கணும்னா you have to take ஒரு நூல் எடுத்து இந்த பாத்தில் இப்படியே ஃபிக்ஸ் பண்ணி வச்சுட்டு அந்த நூலை ஸ்ட்ரெச்சன் பண்ணிங்கன்னா அது ட்ராவல் பண்ண டோட்டல் டிஸ்டன்ஸ் வந்து உங்களுக்கு கிடைக்கும். Now the corresponding things that are derived are velocity and speed. Velocity is nothing but the rate of change of displacement is velocity, and the rate of change of distance naturally is called speed. So naturally the velocity happens to be a vector and the speed happens to be a scalar. Now the unit is actually, so the rate at which the displacement is changed, so you can say it is displacement divided by time, and naturally the unit is going to be meter per second. Since the SI unit of displacement is meters and the SI unit of time is seconds, the unit is meter per second, or you can write it as ms power minus 1. And the dimensional formula for velocity, so we are talking about velocity, so the L t power minus 1. So it is the same case for distance also, for speed also, because speed is distance by time, and the units and dimensional formula are the same as that of velocity. So remember, velocity is a vector quantity and speed happen to be a scalar quantity, and the unit is meter per second, and the dimensional formula is L t power minus 1. Now very importantly, the rate at which velocity changes is called acceleration. So now naturally acceleration is velocity by time. The unit will be the unit of velocity is meter per second, and that of time is second, so we'll get meter per second square s power minus 2, and naturally the dimensional formula is L t power minus 1 divided by t, or we can say it is L t power minus 2. So acceleration. So we have seen that the velocity is actually the rate of change of displacement and acceleration happen to be the rate of change of velocity. Now let us come to the simplest kind of motion, that is what we call as the motion along one dimension. Let us see what is meant by motion along one dimension. Suppose say the point object that we have considered can move only along a line. So let the object move only along a line. So whenever we start analyzing motion and kinematics, we fix a point called the origin. It is a reference point. Now I say the object is 2 centimeters away from the origin. So it will be over here. Say 2 centimeters or 2 meters or whatever it may be. So this is the position of the object. If the object is moving along the line only. Suppose say I can use negative numbers also. I say the object is at minus 2 meters in the origin. Then I take 2 meters on the left hand side of it and say the object is here. So just by mentioning a single number, it can indicate the position of the object if you have an origin fixed. So origin and the object position kandupidikiradhukku, if you need only one number, then you call that kind of motion as an one-dimensional motion. This happens when the motion of the object is restricted to a single line. Say, for your understanding, I will tell you one thing. Suppose it is not the case that it is restricted only to a line. Suppose the object can move everywhere along this plane. Then I fix a point and say, now the object is at 2 centimeters away from the origin. Then the object can be 2 centimeters over here, or 2 centimeters over here, or 2 centimeters over here. In general, it can be anywhere along this circle of 2 centimeter radius. So if the object can move in a plane, then one number will not be sufficient to determine the position of the object. Then that kind of motion cannot be called as one-dimensional motion. So one-dimensional motion is the motion in which the object moves only along the line. ஒரு லைனில் மட்டும் அந்த ஆப்ஜெக்ட் மூவ் ஆகிட்டு இருக்குதுன்னு எனக்கு தெரிஞ்சேனாக்கா, once I fix an origin by a single number, I can find the position of the object at any point of time. Say, I am telling the object is at x centimeters away from the origin, then precisely the object is going to be at some point x away from the origin. And negative numbers can be used to distinguish it on the left hand side. So if we use numbers starting from negative infinity to plus infinity, like all the whole numbers that you have, then you need only a single number to find the position of the object. A single number. That is why I call this kind of motion as one-dimensional motion. That is the object moving along a line. So this is the simplest case of motion. Coming to one-dimensional motion, again the object is moving only in a single line. There is something known as a uniform motion. So what is uniform motion? That is when the object is moving with a constant velocity. So the velocity of the object remains a constant, or in some way you can say it covers equal distance or equal displacement in equal interval of time. So the velocity remains a constant. So such a motion is known as uniform motion. Now there can be a motion with constant acceleration. So the object is increasing the velocity at a constant rate. That is, the rate of change of velocity remains a constant. Then such a motion is known as a motion with a constant acceleration. So considering motion with a constant acceleration, if the value of acceleration is 0, so here the acceleration is a constant. So 0 is also a constant. So if this constant's value is 0, then it becomes uniform motion. So this is a more general kind of motion in which the object's acceleration is a constant. That is, its velocity increases at equal rate. Now, the motion can be more complicated than that. Plus 1 level this is the kind of motion that we are focusing on. That is, the acceleration of the object remains a constant. That is, the velocity of the object increases or decreases at a constant rate as the time flows. Now, a serious mathematical analysis of this motion, that is the motion with constant acceleration, was done by Galileo. Galileo thought the mathematical apadicharu, and our 3 equations he derived, which are very useful equations. And the 3 equation you can do any problem related with the motion with the constant acceleration. நம்ம வந்து ஃபஸ்ட் அது 1 dimensional மோஷனுக்கு படிப்போம். அதுக்கப்புறம் we will generalize it for 2 dimensional motion. அதுதான் நம்ம ப்ளஸ் ஒன்ல வந்து ஃபஸ்ட்டு 2-3 சாப்டர்ஸில் ஃபோக்கஸ் பண்ணக்கூடிய விஷயம். தட் இஸ் வெரி இம்பார்ட்டண்ட். இந்த 3 equations வச்சு you will get n number of problems in all the competitive exams and we will solve certain problems. அதுக்கப்புறம் வந்து we will be combining this formula with the topic called vectors that we have already learned. அது ரெண்டு கம்பைன் பண்ண ப்ராப்ளம்லும் we will solve it out. So இந்த மாதிரி problems are very important and let us see how Galileo derived at these equations. So now we are going to focus on one-dimensional motion with constant acceleration. And the equations he derived are normally called as Newton's equations of motion, of course, but they were actually derived by Galileo by using some principles of geometry, and we will see what those equations are. They are very simple equations. The velocity, acceleration, displacement இந்த சொல்லக்கூடிய விஷயங்களோட definitionalne you can derive those equations, and they are very useful equations. As now we will try to derive those equations. Now we are considering one-dimensional motion with uniform acceleration. So the acceleration of the object வந்து or velocity of the object வந்து ஒரே ரேட்டில் வந்து இன்க்ரீஸ் ஆகிட்டே இருக்கும். சப்போஸே நான் observation ஸ்டார்ட் பண்ணும்போது, so when you start an observation you can fix the time t equal to 0. So t equal to 0 சொன்னீங்கன்னா always நம்ம observation ஸ்டார்ட் பண்ணக்கூடிய டைம், அந்த டைமில் at t equal to 0 let u be the velocity of the object. So it is uniformly increasing. Say after a time t, that is I will say t equal to t, after some time t, let the velocity become v and let a be the corresponding acceleration. Now I know that acceleration is nothing but the rate of change of velocity, that is change in velocity divided by time. எனக்கு தெரியும் the velocity has changed from u to a velocity of say v in a time of t. So change in velocity by time is the acceleration divided by time. So the change in velocity is nothing but v minus u, because the velocity has changed from u to v, divided by t. T is the time taken, is actually the acceleration a. Or I can say v minus u equal to at, or v is equal to u plus at. So this is called the first equation of motion. It's a very famous equation. It is nothing but the definition of acceleration, and the equation is rearranged into a beautiful form. So this is known as the first equation of motion. Equation of motion in the sense means motion along one dimension with uniform acceleration. So one dimensional move agara object, if it maintains a constant acceleration, then the first relation or the first equation of motion is v is equal to u plus at. So டைமை பொறுத்த வரைக்கும் velocity எப்படி சேஞ்ச் ஆகுதுங்கிறது தான் இந்த equation that gives. It's a very important equation, very useful equation. Now let us derive the second equation of motion for uniform acceleration. So velocity வந்து uniform rateல change ஆகிட்டு இருக்கும் பொழுது, அதாவது when the acceleration is a constant, the displacement can be written as the average value of velocity multiplied by time. The formula one you can use it only when the acceleration is a constant. That one the further we will analyze it later. So displacement can be written as the average value of velocity multiplied by time. So namakku theriyum the velocity of this object is starting from u and becoming v in a time of say t. Now I can write the average value of velocity as v plus u divided by 2. That is, I am taking the average of initial velocity and final velocity. Let displacement be denoted by symbol s. Then I can say s equal to u plus v divided by 2, that is average value of velocity, multiplied by the time taken, say t. Now already from the first equation I know that v is equal to u plus at. Now the value when I am putting it over here in this v, then I can say this is equal to u plus at divided by 2 multiplied by t. Or I can say it is 2u plus at divided by 2 into t is equal to 2u by 2 plus half at into t, or I can say this is equal to ut plus half a t square, that is s. So when the displacement or acceleration of the object is a constant, then I can say the displacement s is equal to ut plus half a t square. So this is the second equation that we are talking about, and it is quite easy. இப்போ நம்மளுக்கிட்ட ரெண்டு equation இருக்கு இல்லைங்களா? So v is equal to u plus at and s equal to ut plus half at square. So two equations for an uniformly accelerated motion. So first equation வந்து அது என்ன காட்டுனாக்கா, as the time goes on how the velocity changes. So if the first equation is the relation connecting velocities and time. Second equation is the relation connecting displacement and time. Now it is quite easy. I want a relation between velocity and displacement. So displacement போக போக how the velocity value changes. அதுக்கு ஆன்சர் வந்து ரொம்ப சிம்பிள். இந்த ரெண்டு ஈக்குவேஷனும் டைமை எலிமினேட் பண்ணால் போதும். ஸோ ஐ நீட் டைம் இண்டிபெண்ட் ஈக்குவேஷன். ஸோ ரெண்டு equation வருது டைமுக்கு சால்வ் பண்ணேன்னா you are going to get the second equation. Quite easy. Solve time from the first equation. From here I can write at is equal to v minus u, or t is equal to v minus u by a. In the value one I am going to put it in the second equation. So instead of t I am going to write v minus u by a. So s equal to u into v minus u by a plus half a into v minus u by a square. U into v minus u by a plus half into a into v minus u square by a square. So in the a square cancel ஆயிடும். So this a goes off and this a square becomes. இதை வந்து I can write it as uv minus u square by a 2a into v minus u square. Now the LCM is 2a. I can write it as 2a 2 into uv minus u square plus v minus u the whole square. Let us open this using a minus v the whole square. So I can say 2 into uv minus u square plus v square minus 2uv plus u square by 2a equal to 2uv minus 2u square plus v square minus 2uv plus u square. So in the minus 2uv plus 2uv cancel ஆயிடும். Minus 2u square and plus u square will give minus u square. So I can write v square minus u square divided by 2a equal to s. Now this can be written as v square minus u square equal to 2as. This is the popular third equation. So I have derived all the three equations of motion for uniform acceleration. The first is v is equal to u plus at. Second is s equal to ut plus half at square. And the third is v square minus u square equal to 2as. Very important equations. You get a lot of problems based on these three equations. So first equation one, it connects the velocity with respect to time. That is time poga poga velocity eppadi change agum. Second equation shows how displacement changes with the time. That is as time goes on how the displacement changes. The third equation says how the velocity changes as the distance moves on. The moon equation one, it describes everything about an uniformly accelerated motion in one dimension. Of course இதே equations are applicable to two dimension also. அது வந்து நம்ம அடுத்த சாப்டர்ல பார்ப்போம். ஸோ இது வச்சு எந்த விதமான ப்ராப்ளம்ஸ் எல்லாம் கேட்கலாம். Now we are going to analyze all the sort of problems இதை பேஸ் பண்ணி இருக்கக்கூடிய ப்ராப்ளம்ஸ். இந்த யூனிஃபார்ம் ஆக்சிலரேட்டட் மோஷன் along one dimensionக்கு ஒரு பெஸ்ட் எக்ஸாம்பிள் வந்து ஒரு ஃப்ரீலி ஃபாலிங் ஆப்ஜெக்ட் அண்டர் கிராவிட்டி. ஸோ எர்த்தில் வந்து ஒரு ஆப்ஜெக்டை வந்து இஃப் யூ ட்ராப் இட் from a height அதோட ஸ்ட்ரைட் லைனில் கீழே விழுவும். Imagine that there is no air resistance. Air resistance எல்லாம் ஒன்றும் கிடையாது. Imagine that it is falling under vacuum. So உங்களுக்கு தெரியும், by Galileo's experiment, any object that is falling under the gravity comes down with a constant acceleration. It doesn't depend on the mass of the object. For example, ஒரு 5 கிலோகிராம் ஆப்ஜெக்ட்டும் ஒரு 1000 கிலோகிராம் ஆப்ஜெக்ட்டும் ஒரே ஹைட்டில் இருந்து நீங்கள் ஃப்ரீ ஃபாலிங் அண்டர் கிராவிட்டியில் வந்து இஃப் யூ ட்ராப் இட் they will touch the ground at the same time. இது வந்து ஃபஸ்ட்டு ப்ரூவ் பண்ணது கலீலியோ தான், by a very famous experiment in which he dropped many objects from the leaning tower of Pisa. இப்போ நேச்சுரலாக நீங்கள் ஒரு கேள்வி கேட்குறேன், சப்போஸ் இஃப் யூ ட்ராப் a coin and a feather, why don't they come and touch the ground at the same time? அதுக்கு காரணம் என்னென்னா, it is because of the air resistance. ஸோ ஏர் ரெசிஸ்டன்ஸ், அட்மாஸ்பியருக்கு ஏர் ரெசிஸ்டன்ஸோட எஃபெக்ட்னால்தான் the feather, the object, the motion of the feather is actually affected. So இந்த question வந்து அந்த காலத்தில் கலீலியோ கிட்ட கேட்டாங்க. When Galileo claimed that every object will fall at the same rate on the surface of the earth, Galileo said it may be because of the role of air. And later அது வந்து அதனால தான் நடக்குதுன்னு Newton proved it by creating a vacuum tube and dropping a coin and a feather inside that tube. And the vacuum tube வந்து when he turned it down, both of them touched the bottom part of the tube at the same time. So thus he proved experimentally that every object on the surface of the earth fall at the same rate irrespective of their weight or mass. So an object falling under gravity on the surface of the earth is one of the best examples of uniform motion, uniform accelerated motion in one dimension. So keeping this in mind, we will now try to discuss some popular problems, some simple problems, a bit tougher problems. எல்லாத்தையும் நம்ம இப்போ அடுத்த செஷனில் பார்ப்போம்.